Hello, my name is Mikaela Ferreira, and this work is part of my PhD research entitled Assay-Based Nanoemulsions for Sustainable Cosmetic Applications, Development and Characterization. The authors are myself, João Vitor Latanzi, a graduate student who helped me during the experiments, Francisco Machado, a postdoctoral researcher who contributed to the interpretation of the results and writing, and Leandro Rocha and Caio Fernandes, both my advisors. The cosmetics sector is expanding worldwide, with Brazil ranking third on global consumption. Along with the increasing interest in cosmetic products, growing environmental awareness has also driven the demand for sustainable and natural products. Despite the interest and the presence of major brands claiming natural formulations, the Brazilian industry still lacks products that combine both regional biodiversity and innovative technologies. Açaí is an Amazonian palm rich in polyphenols, such as anthocyanins, which are responsible for its antioxidant activity. However, intrinsic characteristics of natural products, such as lower water solubility, limit their incorporation into aqueous systems. In this context, nanotechnology enables the incorporation of hydrophobic compounds due to its nanoscale size, improving protection and stability. Therefore, the aim of this work was to develop and characterize an assay-based nanoemulsion for cosmetic application. To achieve this, we used phytoglycerin assay extract and assay oil, both obtained from the berries. The extract was characterized by Folin-Siocato and differential pH methods, while the fatty acid profile of the assay oil was determined by GC-feed. Regarding the nanoemulsions, we first tested different surfactants, polysorbate 85 alone, and a mixture of polysorbate 80 and sorbitan monoleate, as well as different phytoglycerin extract concentrations and surfactant-to-oil ratios, ranging from 9:1 to 72:8. All nanoemulsions were prepared using a low-energy method and analyzed both macroscopically and by dynamic light scattering. After screening, we selected the optimal nanoemulsion. The selected nanoemulsion was then evaluated according to Anvisa guidelines on the different storage conditions, including oven, refrigerator, room temperature, freezer, and freeze-thaw cycles. Mean droplet size, polydispersity index, zero potential, and macroscopic characteristics were monitored over 14 days. The results revealed that phenolics and anthocyanins averaged 7.2 and 9.6 milligrams per milliliter, respectively. Oleic and palmitic acids were the major compounds of assay oil, and these findings are consistent with the scientific literature. A total of 16 nanoemulsions were prepared. After screening, we selected a formulation containing polysorbate 80 and sorbitan monoleate, 5% of phytoglycerin assay extract, and an 18:2 surfactant-to-oil ratio. This nanoemulsion exhibit a mean droplet size of approximately 100 nanometers, PDY of 0.3, and a zero potential of minus 13 millivolts. The formulation remained stable under most conditions, except for freeze-thaw cycles and oven storage, as shown on the images on the right, where the nanoemulsions lost its initial macroscopic characteristics. This behavior might be related to the decrease in droplet size during heating, which probably accelerated the instability process, such as Ostwald ripening. In conclusion, despite lower stability under heating conditions, we were able to successfully develop an assay-based nanoemulsion that showed good stability over time under most storage conditions. This formulation demonstrates potential for sustainable cosmetic applications, and as a result of this work, we have already filed a patent covering both the preparation method and the developed formulations. Thank you for your attention.